Welcome to Redox chemistry classes. In this video, I am going to discuss about balancing of redox reaction. This is one of the important topic in stoichiometry. Stoichiometry is the one of the topic in intermediate first year chemistry.
In my previous video, I have discussed about what is redox reaction and various types of redox reactions. We have discussed about what are redox reactions and various types of redox reactions. We know that redox reaction means the reaction in which both oxidation and reduction occurs simultaneously. Both oxidation and reduction occurs simultaneously are called redox reactions. Both oxidation and reduction occurs simultaneously are called redox reactions. Here, these redox reactions can be balanced by. Redox reactions are balanced by two methods. One is ion-electron method, and second one is oxidation number. Another one is oxidation number method. So the first one is ion-electron method and second one is oxidation number method. In this video, I am going to discuss about balancing of redox reactions by ion-electron method. So the balancing of redox reaction is one of the important topics in intermediate public examination point of view. Now, let me take one example. Then we can discuss step by step how to balance a redox reaction. Ion-electron. In this method, first, what is the first step is the given redox reaction should be split into two half reactions. That is oxidation half reaction. And reduction half reaction based on the oxidation state. This is the first step. What we need to do is, in ion-electron method, the first step involves splitting of given redox reaction into two half reactions. That is oxidation half reaction and another is reduction half reaction. The splitting can be done based on the oxidation state, whether oxidation state of a particular element increasing or decreasing. Based on that, these redox reactions can be split into two half reactions, that is oxidation half reaction and reduction half reaction. Now, let me take one example. Cr2O7 2- plus Fe2 plus is raised to Fe3 plus plus Cr3. So this is the given redox reaction. Now, what we need to do is we need to split this reaction into two half reactions. One is oxidation of reaction, another is reduction of reaction. Now, let me discuss based on the oxidation state of iron and chlorine. Now, what is the oxidation state of chromium in dichromate? In my previous video, I have discussed how to find out how to determine the oxidation state. So we need to know, we need to assume the oxidation state of chromium is X. That's right, because two chromiums are there, that's why it is 2X. Plus 7 oxygens are there, and oxidation state of each oxygen is -2. That's why 2X minus 14 is equal to -2. 14 minus 2X is equal to +6. Here, for an ions, the oxidation state of ion in an element is oxidation state of an element in an ion is equal to its charge. That's why here oxidation state of chromium is +6. Chromium is +6. Here it is a +2. Here it is a +3, and here it is also +3. Here it is also +3. Here oxidation state of chromium in dichromate is +6, and oxidation state is +2. Here what happened? The oxidation state of chromium is decreasing from 6 to 3, +6 to +3. That's why it is called reduction of reaction. Reduction of reaction. Whereas oxidation state of iron is increased from +2 to +3. Oxidation state of iron is increased from +2 to +3. That's why this is called oxidation of reaction. This is called oxidation of reaction. You see, based on the oxidation state of a particular element, particularly here, other than oxygen, nitrogen, whatever elements are there, for those elements, generally we use it to consider, we use it to find the whether oxidation state of a particular element increased or decreased. Increased or decreased. So this is the first step. Split the given reaction into two half reactions. One is oxidation of reaction, another is reduction of reaction. This is the first step. Split the given redox reaction into two half reactions. One is oxidation of reaction, another is reduction of reaction. This should be done based on the oxidation state of a particular element, whether it is increasing or decreasing. If it is increased, it is called oxidation. If it is decreased, it is called reduction. It is called reduction. So the given reaction should be, the given redox reaction should be split into two half reactions. One is oxidation of reaction, another is reduction of reaction. Reduction of reaction. After splitting into two half reactions, so they divide the piece into two parts. So you write, divide like this. One is oxidation of reaction, and another is reduction of reaction. So in the previous step, we have divided Fe plus 2 to Fe plus 3. And here chromium Cr2O7 2 minus 2 Cr3. So this is the first step. The given redox reaction should be split into two half reactions. One is the oxidation of reaction, and another is reduction of reaction. Now, what is the second step? Second step, balance the elements. Balance the elements other than oxygen and elements other than oxygen and hydrogen. Oxygen and hydrogen. Except oxygen, whatever elements are there, you balance those elements. Here, there is only one iron. In product side also, there is only one iron. That's why no need to balance. No need to balance. Here, therefore, you plus 2. Here, don't confuse. Here, the plus 2 and plus 3 corresponds to charges. It is not the number of iron atoms present. Here, only one iron only present, as there is no superscript here. Subscript here. Here also there is no subscript. That's why assumed to be 1. That's why here one iron is there. Here also only one iron is there. But if you observe this reduction of reaction, you see here there are 2 chromiums are there. There are 2 chromiums are there, but here only one chromium is there. So to balance these elements other than oxygen and hydrogen, you see here you multiply with a sortable quotient. You multiply with a sortable quotient. You multiply with a sortable quotient. Sortable quotient means here, because to get the 2 chromiums, this side we have to multiply with a 2. Right? Other than that, we should not do, we should not remove this, or we should not add 2 here. Just we have to multiply with a sortable quotient. Here, as 2 chromiums are there, to make it to this side also 2 chromiums, you multiply with 2. Right? This is the second step. Balance the elements other than oxygen and hydrogen. Now, third step is balance the oxygens and hydrogens. Balance the oxygens and hydrogens. Now, other elements we have balanced. Now, we need to balance oxygens and hydrogens. We need to balance oxygens and hydrogens. To balance oxygens and hydrogens, you see here, while giving problem itself, they will specify we have to solve by ion electron method in acidic medium or basic medium. In its basic medium. For example, here the given reaction Cr2O7 2 minus plus Fe plus 2. Here H plus, if it is written, it is called acidic medium. If it is written OH minus, it is called basic medium. So balance the given redox reaction in acidic medium or basic medium. They will specify in the question. They will specify in the question whether you need to balance the given redox reaction in acidic medium or basic medium. So whether it is acidic medium or basic medium, in ion electron method, first two steps are common. What are those 2 steps? Split the given redox reaction into 2 half reactions. One is oxidation of reaction, another is reduction of reaction. So after splitting into 2 half reactions, balance the elements other than oxygen and hydrogen. Balance the elements other than oxygen and hydrogen. So now we have balance. Now we need to balance oxygens and hydrogens. You see, to balance oxygens and hydrogens. Oxygens and hydrogens. In acidic medium, to balance hydrogens, we have to add H plus ions. We have to add H plus ions. Whereas to balance oxygens, add H2O molecules. Whereas in basic medium, to balance hydrogens, add H2O molecules. And here, to balance oxygens, add OH minus. See, the balancing of this hydrogen and oxygens may not happen in a single step. You see, we may need to iterate the process until balancing of oxygens and hydrogens. You see, to balance oxygens and hydrogens, in case of acidic medium, to balance hydrogens, we have to add H plus ions. Whereas in acidic medium, to balance oxygens, we have to add H2O molecules. Now, I am balancing the given redox reaction in acidic medium. That's why to balance hydrogens, I have to add H plus ions. To balance oxygens, I have to add H2O molecules, as it is given in acidic medium, and I am solving it in acidic medium. You see, here, if you observe in third step, You see, in reactant side, there are no hydrogens and oxygen. In product side also, there are no hydrogens and oxygens. That's why no need to balance the swabber. Yes, if you take this oxidation, if same reduction of reaction, if you take, here there are no hydrogens, here also no hydrogens. That's why no need to balance hydrogens. But here there are 7 oxygens, but there is no oxygen. That's why to balance the oxygens. You see, previously we have discussed what we need to add water molecules. That's why 7H2. You see, while balancing oxygens, hydrogens were imbalanced. That's why again we need to repeat the process. Because no hydrogens, but here there are 14 hydrogens are there. Because Cr2 was 7 2 minus plus 14H plus gives rise to 2Cr3 plus 7H2. 7H2. See here, while balancing oxygens, hydrogens maybe gets balanced. Whereas while balancing hydrogens, oxygens gets imbalanced. So to complete the balance, what we need to do is we need to iterate the process. Means we need to separate, do again and again and again. Here, based on within 2 steps itself, oxygens and hydrogens get balanced. Now, that 4th step is balance the charges. Balance the charges. Balance the charges. To balance the charges, add electrons. To balance the charges, add electrons. To balance the charges, add electrons. You see, how to count? Here there are 2 problems out there. First one is how many electrons needed to be added and which side, that is reactant side or product side, we have to add. You see, to that we need to calculate the charge. Here if you take now Fe2 plus 3 Fe3 plus, what is the charge on plus 2? Here, what is the charge on it? Plus 3. You see, now we have arrived at 2 questions. How many electrons and how many which side we need to add? You see, there is a thumb rule here. You can remember this. One is you divide big number minus small number. Big number minus small number. Here, what is the big number? Plus 3. Minus what is the small number? Plus 2. You see, that's why 1 electron is needed to be added. 1 electron is needed to be added. You see, now how many electrons needed to be added? Big number minus smaller number. Big number minus smaller number. That's why 1 electron is needed to be added. And it should be added in product side. It should be added in product side. It should be added in product side. That's why. Now it is minus 1. Overall charge becomes 0. Overall charge becomes 0. This is. Now let us come back to this side. You see, what is the charge on this side? Minus 2 here. Because overall charge on this side, Cr2O7 minus is minus 2. Here, 1 H plus means plus 1. There are 14. That's why plus. Here, 1 chromium 3 plus means 3 oxidation number is there. That's why 2 into 3 plus 6. Here it is a neutral molecule. That's right. Now, if you observe, it is a plus 1. What will happen? It is a plus 6. Now, let us again thumb rule. What we have to do? We have to first think, we have to check how many electrons needed to be added. How many electrons are required to be added? One is here 12, here 6. Big number minus small number. Big number minus small number. 12 minus 6, 6. And which side we have to add? We have to add on the bigger numbers. That's why here reactant side we have to add the electrons. But how many? How many? Big number minus small number. 6 electrons. You see, we can check whether we are doing it correct way or not. Yes, if you are doing correct way, here in one off reaction, if electrons are added on the product side, in another off reaction, electrons cannot be added on the same side. You can add in the products reactant side. Getting or not here? Either in the one side, if one off reaction in product side is added, if you have done correctly, then in other reaction, another off reaction, the electron should be added on the product side. Product side. So this is the third step, balancing of charges. You see, to balance the charges, what we have to do? We have to add electrons. You see here, the two questions are came. One is erosion. One is how many electrons needed to be added, and which side we have to add. How many electrons needed to be added? Big number minus small number. We add big number minus small number. If you do add big number minus small number, whatever number comes, that is corresponds to the number of electrons needed to be added. And which side we have to add? Which side means that is on the wherever means more positive is there, that side we have to add. That's very simply bigger number side. We have to add the number of electrons, right? Number of electrons. So here now the next step is balancing of charges is also complete. Balancing of charges is also complete. Now next step is, what is our next? Next step is, after balancing of the charges, balance the number of atoms. Means whatever electrons are present on the reactant side should be present on the product side also. You see here, if you take here there are 6 electrons, here there is only 1 electron. So to equalize the electrons, you multiply, cross multiply. Here 1, here 6. You multiply this entire equation with 6, and you multiply entire equation with 1. Entire equation with 1. And if I multiply this, and if you multiply with 1, same reaction will appear. Same reaction will appear. Now, what happened is multiply. What happened? 6Fe2 plus is raised 6Fe3 plus 6. Here the same reaction will come. Now, in first step, what we have done? We have split it into 2 half parts. Now, in the last step, what we have to do is you combine both the half reactions. In first step, we have split the given reaction into 2 half reactions. And here you combine both into a single reaction. 6Fe2 plus this side is over. Now next side is Cr2 over 7 2 mass plus 14 heat plus 6 electrons gives rest. Now come back to this half reaction. 6Fe3 plus 6 electrons plus 2 chromiums plus 7 heat. So you cancel. Is the 6 electrons and 6 electrons getting cancelled? That's why what will happen is 6Fe2 plus Cr2 vote 7 2 minus plus 14 heat plus gives us to 6Fe plus 2 plus 2 Cr3 plus 7 heat. So this is the balanced redox reaction. This is the balanced redox reaction. Here we can check whether the balance is correct or not. Reactant side, product side. Now how many iron atoms are there? 6. Here also 6. And chromiums. How many chromiums are there? 2. And how many oxygens are there? 7. Reactants. Product side also 7. Hydrogens. 14. And what about charges? You see, here it is a plus 1. Here it is a minus 2. Here it is a plus 1. Here it is a plus 12 and plus 6. You see, if we remove all the things, plus 14 and plus 1, what will happen? Here plus 3, sorry, plus 3, plus 18. what will happen? Here 26 minus 2, 24 charges. Charges how much? 24. This side also 24. You see, if we have checked the cross verify, if you verify again, this is the way cross verifying our method is correct or not. You see, this is the way to balance the redox reaction. Now let me explain rules one by one more time. You see, in any redox reaction, these redox reactions can be balanced by two methods: ion electron method, and another one is half-life oxidation method. In ionic electronic method, there are 5 steps are there. One is split the given reaction into two half reactions. Split the given reaction into two half reactions. So this is the first step. Split the given reaction into two half reactions. Then second one is, after splitting into two half reactions, balance the elements other than oxygen and hydrogen. Balance the elements other than oxygen and hydrogen. And third one is balance the oxygens and hydrogens. Balance the elements oxygens and hydrogens. This is the third step. This is the third step. Whereas in fourth step, after balancing the oxygens and hydrogens, now fourth step is balance the oxygens and hydrogens. After balancing the oxygens and hydrogens, balance the charges, and after balancing the charges, what we have to do is we have to equal the number of electrons, make equal the number of electrons in both the off reactions. You see here, to make equal, just we need to multiply the cross multiply. We have to cross multiply. After equalizing the electrons, combine both the off reactions. Combine both the off reactions. So this is the way to balance the redox reaction by ion electron method. Ion electron method. Now let me take another example and let me discuss. Now I will not discuss the rules, but just simply I will balance the equation by this ion electron method. By ion electron method. You see, what is the difference between normal balancing and this redox reaction balancing? In normal balancing, just only number of atoms on the reactant side and product side should be same. But here, charges are also come. Let me take another example. MnO4 minus plus I minus is raised to Mn plus 2 plus I. Mn plus 2 plus I. Now, here, oxidation number of Mn is how much? Let it be x. 4 into minus 2 is equal to minus 1. X is equal to plus. That's why it is plus. Here it is a minus. It is a plus. It is a 0. It is a 0. Now, see what happened? Oxidation state of manganese is what happened? Decreased from plus 7 to plus 2. That's why it is a reduction. Here it is increased from minus 1 to oxidation. Minus 1 to 0. It is oxidation. Now split the reaction. Reduction of reaction. Oxidation. Oxidation of. Now what is the first step? MnO4 type. Mn plus 2. So we have split it into two half reactions. Now balance the elements oxygens and hydrogen. Here manganese is there, here also manganese is there. 1, 1. That's why no need to balance. MnO4 minus 2. Mn plus 2. Here, there are two ions on the product side, but only one ion on the reactant side. 2I minus is raised to I. Now, third step is, now I am doing it again in acidic medium. That's why to balance oxygens, what we need to add? So to balance one oxygen, we need to add one water molecule. That's why here it is 4H2. And again, iterate the process to balance both oxygens and hydrogens. 8H plus gives rise to Mn plus 2 plus 4H2. Here, no need to balance because there are no hydrogens and oxygens. Now, balance the charges. Here it is a -1 charge. Here it is a +8. Overall, how much? +7. Here it is +2. Mn +2 is +2 charge. H2 is 0 charge. That's why overall charge is +2. Now, how many electrons needed to be added? Bigger number minus smaller number. 7 minus 2, 5. 5 electrons needed to be added. And here if you take -2, 0. That's why we need to add the 2 electrons. Bigger number is 0. 0 minus 2 is 2. Gives rise to I2 plus 2 electrons. Here we need to add the 5 electrons. You see, MnO4 minus 8H plus 5 electrons gives rise to Mn plus 2 plus 4H2. 4H2. Now, electrons are also, charges also got balanced. Charges also balanced. Now, equalize the number of electrons. For that, what we are doing is just cross multiply. You see, here there is a 2 electrons. Here there are 5 electrons. That's why you multiply this equation with 2 MnO4 plus 8H plus 5 electrons gives rise to Mn plus 2 plus 4H. You see, here 5 you multiply with 5. Then 2I minus gives rise to I2. 2I minus gives rise to I2. That's why you multiply now. 2 MnO4 minus plus 16H plus 10 electrons gives rise to 2 Mn plus 2 plus 8H2. Here whatever 10I minus gives rise to 5. Now balance the charges. Now balance this. So combine this both the half reactions. Now both the half reactions gets balanced. Now combine both the half reactions. If we combine now, what will happen? 2 MnO4 minus plus 16H plus 10I minus gives rise to 2 Mn plus 2 plus 8H2 plus 5. So this is the way to balance the redox reaction by ion electron method. Now you can check yourself whether it gets balanced or not. It's a balanced redox reaction. So it is one of the most important topic for intermediate public examination point of view. Thank you.